Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look at using pointers with your application. Before launching into our code, it's worth saying a little about memory management in Windows. In the distant past, before Windows and other modern operating systems, when the amount of memory your computer had was very much smaller, programmers only needed to think about where in physical memory their program and data resided. In those days, there would only be one process running on the computer: your own. Today, memory management is a little more complicated, although you as a programmer are shielded from much of this complexity. The Windows operating system maintains a virtual address space for your program. This cannot be accessed by other processes unless it is shared. What you are looking at here on screen is the resource monitor of the Task Manager, showing the current usage of this computer's memory. As you will see, some memory is in use. Some is on standby, and some is free to be allocated to processes that require it. Windows maintains a page table for each process running that maps the virtual address to the physical address in memory. So even if your program is moved around in memory by the Windows operating system, everything will still just work, without you having to do anything special in your code. Now to our code. Pointers, what they are, and what you can use them for. Now, to illustrate the use of pointers, we're going to create a small, very basic array. So we've created a string array of 10 elements, a single dimensional array. We're going to populate that array with some values. So we've now assigned a value to each of the 10 elements of our simple string array. In issuing these commands, what PowerBasic has in fact done for you is allocated an area of memory into which this information is put. As you amend the values within that array, PowerBasic behind the scenes, in cooperation with Windows, will effectively create a new area to contain the array, which could be larger or smaller, and it will copy the information into that memory location. But again, this is something that's shielded from you, and all you have to worry about is what change you wish to make to your array. Having created this array, we may want to pass the array to another subroutine or function for further processing. So we're going to create a small function called funProcess, and we're going to be passing this array to this process. So we've created the skeleton of our process, and we're passing the array by reference. Now what this actually means is you're not actually passing the data that's contained within the array. You're passing a reference to where it sits in the virtual memory space. This tells the function that the array, which we're referencing in our original function called strlist, we're referencing it in the other function called adata, but is in fact this same array. We're just using a different name from it in the other process. You can do this quite happily, and it means many different functions can call this one common function to pass an array in. All we're doing is we're telling the function that it is a string array, we're passing the reference, and the function will accept it quite happily. And since we're passing it by reference, this would allow the function funProcess to make amendments to the array, and when we pass control back to the calling routine, it would also have those updates, because the information is at the same memory location. Now, if we want to actually look through to prove that the information has indeed arrived, we can do a simple for next loop to throw this out to our log. So all this little for next loop will be doing, we're going from the first element to the upper bounding of the array, which in this case we know happens to be 10. And for each element of the array, we're pushing it out to our log. So if we try running that program now, we'll see that the values in our subroutine of each element of the array are being pushed out to the log. So we can confirm that the data in our array, strlist, has been passed by reference to our process, and although it's referencing it by a different name, it's still in the same location, it's still the same data. So how could we use a pointer to do something similar? Well, if we go back to our original array. Now we're going to comment out our original process and we're going to create a new variable. And this one is going to be a string pointer called parray. So all we have to do is to point this string pointer at the beginning of the array. So we're using the var pointer command with the first element of our array as the parameter. And this value is stored in parray and we can then pass it to our function. So if we create a new function to actually handle this. Now the parameter we want to pass is parray. Now the other variable we want to set up here is a variable to tell us how big this array is. Since we're just passing the location in memory where this array actually resides, we're not actually saying how big the array is. So it's useful if we actually determine that and pass that. So we've created a variable called longmax, and we're using the ubound command to work out what the upper bounding element of the array actually is. So this value going into longmax would be 10 because it's the upper bound of the array. So we'll pass that as well to our new function. Now for these pointers we're going to have to pass it by value. So we're now passing two parameters to our new function. We're passing parray by value as a string pointer and longmax as a long. Now if you see sometimes people abbreviate pointer to be ptr, it's exactly the same thing. So having passed both of these variables, what do we do next? Well, in our original function we declared a local variable, which we will do, and we're going to do a for next loop, just as we did before, only this time we're going to be using it in pointer format. Now, although our array was originally set up as between elements 1 to 10, when you're passing these using pointers, you always start at 0. And since we passed the upper value to be 10, we'll use a -1, so it'll go from 0 to 9. Now, how do we actually put this out to the log? Well, it's much the same approach as we did before, only with a very slight difference. Since we're talking pointers here, we use the @ sign and then the name of our pointer, and then in square brackets we put the element we're actually dealing with, which case is long R. And that's it. If we try running that process now, I forgot to declare the end of the return, we'll see we're getting exactly the same output as we did before. Only this time we're using a pointer. But you may very well ask, why? Why would we want to take this approach? Because we are in effect achieving exactly the same thing, first of all by passing a reference to the original array, and secondly by passing a pointer. The ultimate output we're getting is exactly the same. So what's the advantage in actually using a pointer? Well, let's assume that we actually had more than one array. Let's assume we had two arrays. So we will prep a second array, which is a different size. So we now have a second array, strListNew, which has only got 5 elements in it and some different data. Now, you may on occasion want to write generic functions, and this is where our pointers come in very useful. Suppose you had something in your code that pulled information back from perhaps a database or the user's input, and it's going to assign a value to this variable, long value. And depending on that value, you may wish to perform some operation on either the strList array or the strListNew array. Now you can quite easily do that with a simple if command. If it's equal to 1, you could call our first function, and if it's not equal to 1, you could call our second function. This would involve an if statement and two separate calls to two different functions. But using a pointer, we can get away with only calling one function. What we will do is we will do our if command, as we would have done, and if the value equals 1, what we will do is we will pick up this. Let's comment that line out for the moment. And if it's other than 1, then we will point it towards the other array. And we'll want to use our max command to pick up the size of the array. And we'll comment that out as well. Now if we do this, then the function we have already written will operate perfectly reasonably well with both of our arrays. So let's have a look. We've set it to value 1 at the moment. So if it's value 1, it's going to push the information out from the original array, which is the letters. If we run that now, it will push out the original array. If we change the value to, for example, 2, it should push the information out from the second array, which it does. So we have now written one generic function which will push information out based on the array which it is pointing at, saving you additional code. This is just the beginnings of what we can do with pointers. But that's it for today. Thank you for watching.